Alright, this is the part 3 lecture video of 3.4 Polymers. It's going to be the last video as well for Unit 3 molecules. Alright, we'll be looking at two last items in the science understanding table here. So organic polymers have diverse properties and uses, and also finally the properties of organic polymers depend on the interactions between the polymer chains. Slides that I'm gonna be using starts from slide 13 here. Alright, so polymer properties. Now, a lot of polymers we see on the market or whatever items that's being made with polymerization, they are purpose-built. They are built to have certain purposes. Of course, some of them came out in the past as accident, but from that we discovered what sort of things we can mix together to get, desired properties. When we talk about those properties, what are we talking about? Well, there's a list up there. So things like resistant to chemicals, thermal insulator, and heat resistant, electrical insulator, lightweight with significant strength, abruption resistant, yes. Hard or flexible, you can make it either way. Relatively cheap to produce. It's of course comparing to something that happens in nature, like something that's available in the nature might take long time instead of you having some chemicals mixed together and get the same a material which has the same sort of property. Non-stick can be used to make items where there is no other alternatives. Almost limitless range of characteristics and colors. You can make it thin, thick, durable, brittle, whatever you like really. As long as you know the combination and what sort of, budget do you have, time you have, the possibility is limitless. So polymers are made into, a purpose. Every polymer that exists on the market, they all have different purposes. Okay. Now, when we talk about those properties, there's one property, shouldn't say one, but one property that is made into one of the most useful things to talk about when it comes to production and also recycling. That is thermoplasticity. Thermal is heat, plasticity is how malleable that becomes. So when you heat up, how easy it becomes another shape. How moldable it is when you apply heat. That's what thermoplasticity is. Now, polymers mainly can come in thermoplastic polymer or thermoset polymer. Thermoplastic means it's moldable and you can made into any shape really. And that's how 3D printers work. You heat up and make into a bit moldable shape and to put it together to make bigger stuff. Synthetic polymers are the main component of most plastic materials, and thermosetting ones are also one big category of plastic that is available in the world, because plastic in general are very resistant to chemicals. They do not conduct electricity, so insulator, it works as insulator really well. But the problem could be occurring when the plastic's exposed to heat. Some plastic, which is thermoplastic, they would melt. And you don't want that to happen for, say, light fixtures or where electricity is. Because when the electric current goes through it, heat is being generated. Or when you're cooking as well, you don't want, say, the handle for your frying pan to start melting in front of you. So people would have used thermal setting plastic. So hope you see the difference. Now, if you're feeling it's hard to picture, think of butter and pancake, which you can see above here. So butter is something like thermal setting, thermoplastic, okay? Butter would melt and becomes different shape. Of course, once it cools down again, it becomes solid again. Thermal set one is something like pancake. Once you cook it, you can't change the shape, and you can't make it into a liquid again, because it's already set. It will probably just burn even if you try to cook it or heat it up again. Here are some comparisons. So thermoplastic polymers, firstly, exhibit weak intermolecular forces between, how come they are in two words? Intermolecular should be one word, sorry about that. Between individual polymer chains. And because of that, lower amount of heat is required to overcome this IMF, intermolecular forces, and easily softened and reformed. That means it's easy to recycle. More suited to plastic where recycling is desired. So think of something that's recyclable, like PET, polyethylene terephthalate bottle that makes up water bottles. Usually they are usually recycled because they are thermoplastic. It melts easily. Whereas thermoset polymers, because they have got covalent bonds, it's a primary bond between chains. So in thermoplastic, you had chain and chain, they're just interacting with intermolecular force. But in thermosetting, they are connected with primary bond. So individual polymers are connected with it, and higher heat is required to overcome that primary bond. Now, if you apply too much heat, instead of breaking the bond and making it liquid, so once it's formed, okay, they start charring or burning. So instead of becoming liquid, you would be making carbon dioxide, which is combustion reaction, not physical reaction of melting. Therefore, thermoset polymers are more suited for something that's much stronger, durable. You don't want them to burn down or melt so quickly. For example, thermoplastic, PVC. PVC pipes are a very good example. It's very easy to mold. You just have to heat it. You can even do that with a heat gun in your garage. Whereas thermoset polymer can be something like car tires. It's rubber. Whoa, rubber originally comes from a tree sap. It used to be liquid, but by adding sulfur to it, you can make it into vulcanized rubber. Vulcanized rubbers are much more durable. Well, you want that property to be there when you are driving your car on it. It's touching the ground and it keeps spinning, and you want that to be quite strong. I'll show the image there. So on the left, you can see PVC pipes in different shapes, and if you want to remold it, reshape it, you can just heat it up and do that. Whereas for car tires, you can see sulfur chains happening between the chains. So those cross-link that's happening there is making the rubber highly resistant to wear and tear. So that's the difference between thermoplastic polymers and thermoset polymers. And they're just one of those properties that can be changed. Again, polymers are purpose-built. All the polymers have a different purpose, and they made into have certain properties that people like. So there's a sheet connection there as well. All right, that's it. That's the end of topic 3, molecules. All right, I'll see you in topic 4 videos.